Welcome to Spaceverse, your portal to cosmic adventures. For a long time, astronomers believed galaxy formation followed a very specific model. Cosmic gas collects in clumps, stars are born from those clumps, and over billions of years, stellar neighborhoods gradually increase in size. It was neat, predictable, logical. But then came the James Webb Space Telescope, launched in December 2021, and like many great discoveries in science, it brought disruption. In one of its most surprising findings so far, Webb revealed something astonishing. Three massive galaxies, now dubbed the Red Monsters, that already existed just 1 billion years after the Big Bang. Now, just to put that into perspective, the universe is about 13.8 billion years old. So, 1 billion years after the Big Bang, that's infancy. Cosmic infancy. Back when the universe was still finding its footing, or rather, its gravity. These red monsters, each nearly the size of our Milky Way, are galaxies that shouldn't exist in that early time frame. How did they grow so big, so fast? That's the mystery now gripping cosmologists around the world. Initially, astronomers expected to find smaller, less developed galaxies in that era. They were looking for the building blocks, the galactic Lego pieces of the early universe. Instead, they found skyscrapers. Fully fledged, massive galaxies already in full swing. This isn't just a surprising observation. It's what some researchers have called a crisis in cosmology. If galaxies can grow this big, this fast, then something is missing in our understanding of the universe's evolution since the Big Bang. Of course, science always welcomed skepticism, so naturally alternative explanations emerged. In August, a team of scientists suggested that these galaxies may appear larger and brighter than they really are. Why? Because of supermassive black holes feeding at their centers, known as active galactic nuclei or AGNs. These black holes can give off so much light that they mimic the brightness of massive star populations, potentially throwing off our measurements. So maybe, just maybe, these red monsters weren't truly massive. Maybe they were just putting on a light show powered by hungry black holes. But here's the twist. In this new study, scientists found no evidence of active galactic nuclei in any of the three red monsters. None. That means the intense light we're seeing from these galaxies isn't coming from black holes at all. It's coming from the galaxies themselves. Which brings us back to the big question. How can these galaxies be so massive, so early, without black holes giving them a boost? The study behind this discovery was led by an international team at the University of Geneva. They used data from the FRESCO survey, short for First Reionization Epoch Spectroscopically Complete Observations, gathered using the James Webb Space Telescope. Their focus was galaxies with redshift values between z=5 and z=9. For anyone unfamiliar with redshift, it's basically a way to measure how far away a galaxy is, and therefore, how far back in time we're looking. The higher the redshift, the earlier in the universe's history that galaxy existed. So redshifts of 5 to 9 correspond to a time when the universe was only 1 to 1.5 billion years old. To measure the distances and stellar masses of these galaxies, the team used the FRESCO's near-infrared camera, or NIRCam. This particular setup includes a GRISM spectrograph, which allows scientists to study both the composition and structure of galaxies across vast cosmic time. According to Pascal Oesch, associate professor at the University of Geneva's Faculty of Science and the principal investigator of this program, the instrument on board the Space Telescope allows us to identify and study the growth of galaxies over time, and to obtain a clearer picture of how stellar mass accumulates over the course of cosmic history. From the data, the team analyzed 36 massive, dusty, star-forming galaxies. These were chosen for their intense red color and strong emission lines, clear indicators of being both massive and heavily shrouded in dust. Most of these galaxies aligned pretty well with the theoretical models, which was a relief. But 3 of them didn't. These were the outliers. The ones that were off the charts in mass and star formation rate. These were the red monsters. Now, why are they red? It's not just their name, it's what we literally see in the JWST's images. These galaxies appear red because they contain huge amounts of dust. This dust absorbs shorter wavelengths of light, like blue and ultraviolet, and lets the longer, redder wavelengths through. That's where JWST's infrared vision comes in. Unlike the Hubble Space Telescope, which can't see through thick clouds of cosmic dust very well, JWST captures infrared light. That means it can see what lies behind the dust, and that's exactly how it spotted these red monsters. And it gets even more interesting. The JWST data reveal that these galaxies are forming stars about 2 to 3 times more efficiently than galaxies in the later universe. That's not a small difference, that's a massive leap in cosmic productivity. The stellar masses of these galaxies are so large that, in order to reach them in such a short time, they would have needed to convert roughly 50% of their available gas into stars. To compare, galaxies in the modern universe typically convert only about 20% of their gas into stars, and that's already considered quite active. So not only are these galaxies big and old for their time, but they're also incredibly efficient star factories. That raises the question, what conditions in the early universe allowed for this level of galactic overachievement? Lead author Mengyuan Xu, a postdoctoral researcher at University of Geneva, summed it up best. Our research is transforming our understanding of early galaxy formation. But don't expect immediate answers. The causes of this rapid growth are still unknown. Scientists are now exploring possibilities like higher gas availability in the early universe, faster cooling rates, or other physical conditions we haven't yet accounted for. Maybe the rules were just different back then. To find out, astronomers are planning future observations with JWST and also with another powerful observatory, the Atacama Large Millimeter Array, or ALMA. Located in the high desert of Chile, ALMA can observe submillimeter wavelengths that are ideal for studying cold dust and molecular gas, the fuel for star formation. Together, JWST and ALMA might be able to crack the case of the red monsters, revealing how such colossal galaxies emerge from the cosmic fog so early. As Xiao put it, as we study these galaxies in more depth, they will offer new insights into the conditions that shaped the universe's earliest epochs. The red monsters are just the beginning of a new era in our exploration of the early universe. And that's the truly exciting part. The discovery of the red monsters doesn't just challenge our existing models, it invites us to ask new questions, to push further, to reimagine the universe's timeline. These galaxies aren't just ancient relics. They're clues. Clues that tell us our cosmic story may be far more complex and fascinating than we ever imagined. So next time you look up at the night sky, remember, some of the universe's most mind-bending surprises are only just now coming into view. And we've barely scratched the surface. And that's it. Thanks for watching Spaceverse. If the red monsters taught us anything, it's that the universe is full of surprises, even galaxies that grow faster than we ever imagined. Stay curious, stay inspired, and keep looking up. The cosmos is just getting started.